Hello everyone, this is Dr. Chandrasekar from Division of Chemistry, Department of Science and Humanities, Vignan Foundation for Science, Research, Technology and Research. And I will be your tutor for today's class. And the topic which we are going to see today is electrochemistry, which is part of engineering chemistry syllabus and finds application in a lot of industrial as well as household applications. Right? So quickly we will go through the contents or the syllabus which we are to cover in this class. So we will start with the introduction, where we will be seeing the basics, their applications in electrochemistry and different types of cells. Right? Followed by this, we will see the electrode potential, where we will be knowing how to write a cell equation and then how the potential are generated, followed by different types of potentials, and then we can use some equations to calculate the potential generated by this electrode. Right? Followed by this, an important topic which we will be discussing was electrochemical series. This electrochemical series is very much important in electrochemistry. Based on this only, most of the batteries or most of the electrochemical sensors works. So that we will be seeing at the third part of this lecture. And the last one will be Nernst equation. So this Nernst equation is unique in the sense it equates three different properties. One is free energy, chemical equilibrium, and the last is electrode potential. So this finds very much importance as equivalent to your electrochemical series. Okay, so we will be seeing here the derivation for this Nernst equation, and then we will see some of the limitations of this Nernst equation, and that will finish our course. And followed by this course, we will be having another section where we will be discussing about different types of electrodes and all those things, but for our class we will stop up to Nernst equations. Right? Okay, so with this syllabus, the outcome what we are going to achieve will be for the student. Right? So once he goes through this course, he will be confident in applying the principles of this electrochemistry in batteries and in other applications. So that will be one, and he can also able to calculate the electrode potential of unknown electrodes, which is very much essential to design a battery. And third one, he can the student can confidently say whether the reaction is occurring spontaneously or not, or he can also judge, or he can also predict whether the reaction is possible or not. Right? And the last one is he can confidently choose the metal for a battery, which can be used as an electrode, as well as the electrolyte for this battery or any other electrochemical application. So these are the outcomes from this lecture. Right? And coming back for today's class, we will go with the first one, that is the introduction. So where we will be seeing the basics, some applications of the electrochemistry, and then we will see the different types of cells and how it is made and how it works. All these things we will see in the coming class. Right? So quickly we jump into the introduction of our class. Right? So electrochemistry. So by the name itself we can predict, or we can think that this is a two system where one will be electricity and the other one will be chemical reaction. Right? So there are two entities in this electrochemistry. One is electricity and the other one is chemical reaction. By electricity, we already know it is nothing but flow of charges from one end to the other end. But electricity is controlled flow of charges from one end to the other. So it's not like a static current, right? This is a flow of current which is very much controlled, right? And chemical reactions, everybody knows, where two reactants react and it gives a product. This is the video which I am showing up. Right? So these two are two different entities. When these two different entities are put together, and if you are going to assess the property of that material based on these two different entities, that we call it as electrochemistry. So chemistry is a different process and electricity is a different process. We are going to apply both these two things in the system, and we are going to measure the property or study the property of the system. So when we combine these two, that field we call it as electrochemistry. Right? So two different things can happen. Right? So first is the reactions or the chemical reactions might react to form electricity. That is one possibility, and this is very much spontaneous, right? And the second possibility is the electric current can be used to do some chemical reactions, right? So this is the second possibility. The first possibility is chemical reactions can be done to generate electricity, and electricity can be used to do some chemical reactions. So these two possibilities are there in this electrochemistry, right? So these two plays a major role all over the subject. Right? Okay. So once again, I am recollecting whatever I said using those animations. Electrochemistry is a branch of science which deals with the interplay of chemical reactions and electricity. Repeating it once again, electrochemistry is a branch of science which deals with the interplay of chemical reactions and electricity. So in the first one, electricity can be used to do some chemical reactions, which will be a non-spontaneous process. We are driving the reaction by supplying an electric current externally. So this is one way of doing electrochemical reactions, and the second way is, so the example will be an electrochemical cell or an electrolytic cell, and the second one will be chemical reactions can be done to generate electricity. So this is a very spontaneous process, okay, and this will be followed in most of the galvanic or voltaic cells. Right? Is it clear? So, repeating once again from top to bottom, electrochemistry is a branch of science which deals with the interplay of chemical reactions and electricity. There are two possibilities. One possibility is electricity can be used to do some chemical reaction, though it is a non-spontaneous process. By supplying electricity, we can force the reaction to happen. So, this is one process which comes under electrolytic cell. Right? The second process can be chemical reactions can be done to generate electricity, and this one will be a very much spontaneous process, and this will be followed in most of our galvanic as well as voltaic cells. Okay, right. So with this small introduction, we have to think why, what is the need to do to study this electrochemistry? Because this electrochemistry, as I said in the introduction, finds application in most of the industrial as well as household applications. Right? It finds use in most of the fields. It's used in sensors, it's used in medical field, it is used in batteries, it is used in automotive industries, it is used in metallurgy, and it goes on like that. So, application of electrochemistry is wide, and it starts from mere chemical reaction to an automobile or an industrial scale application. So, to we need to study electrochemistry, and to understand the basics is very much required. Okay, so I will show you some of the applications of this electrochemistry, both as well as in household as well as in industrial process, and then we will go on to the second one or the following sections. Right. So this clip will show you some of the applications where the electrochemistry is used to generate electricity, like from solar panels. When then using the semiconductors, you will generate electricity, and this electrochemistry is also used to purify the gases, as I show you here, and it is also used to do some chemical reactions, or it acts as a catalyst to do some chemical reactions, and this electrochemistry can also be used to split water into its individual components, hydrogen as well as oxygen. Right? So in this clip, this shows only this much one, but there are much more applications of this electrochemistry. Right? So coming in detail one by one. So electrochemistry, as I said, it is used in batteries. Right? So batteries, all the normal batteries, whatever we use in our day-to-day life, this alkaline battery is one example of an electrochemical cell, and this battery produces energy, right? And this energy will be in the form of flow of electrons. That electrons will be glowing up the light, whatever the light is glowing here. Right? So that is one application. This is a very small application. The same thing can be made into a bigger one in the case of a lithium-ion battery, which is used in an automotive, cars, bikes, and all the automotive industry. There they use a specific metal oxide or a specific electrodes and electrolytes where the amount of energy produced will be more. So this is one example where electrochemistry is widely used, and the second example will be the second example is electroplating, right? So this electroplating is a process where one metal is coated by another metal with a uniform thickness. So this electroplating you can see in most of the jewelry shops, where the jewels are coated with some gold and silver and all these things, right? So the process whatever they use is nothing but electroplating, where one metal is coated over the another metal, but the coating will be of uniform thickness, right? So this happens by passing electricity to the electrolyte and the electrode, which gets deposited over the respective metal or jewelry or whatever you say, right? So this is one application which finds use in most of the industries as well as in jewelry shop, right? So the third application is electrowinning. So this electrowinning is mostly applicable for copper purification. Copper in its natural ore form, it will be impure, right? So this impure copper ore has to be purified, and this purification process relies on electrochemical process or electrolytic process, where current will be supplied and the pure copper will be deposited on another metal plate, where those copper can be taken out and used for other applications. This is another application for electrochemistry, and this application, the application what we are going to see here, which is a chloroalkali process. This is a very big process and it's a very large industrial process which gives you two different products, right? Simply by breaking a brine solution by applying electricity. Brine solution is nothing but sodium chloride solution, right? Or sodium chloride solution or sodium chloride dissolved in water. So by applying electricity to this brine solution, sodium chloride is going to cleave in presence of water to form a chlorine gas, which will be escaped and is used for industry, and the sodium from the sodium chloride and hydroxide from water react together to form sodium hydroxide alkali, which will be also be used for many applications, right? So this is a very large process where you are going to generate useful products from some commonly available material like brine solution. Sodium chloride is present in plenty in seawater. You take the seawater, apply current and a closed circuit, and it will produce chlorine as well as sodium hydroxide. Both will be used for a large industrial process. Both will be used in a very big application, right? So the other application which I am showing here is purification or extraction of aluminium from its ore bauxite, right? So here we are going to use two electrodes and we are going to pass current, and this current and the electrode will react and it will separate the aluminium present in the bauxite ore, and the aluminium will be removed from the bottom. So these are some of the applications where this electrochemistry finds application both in industry as well as household applications, right? Okay, so with this one we will look back once again whatever we saw. So electrochemistry, as I said, is a branch of science which deals with current and electrical chemical reactions, right? Okay, so in this two process, whatever I said, where in one electricity is used and where in one electricity is generated, in both these processes one thing is very much common. That common thing is loss of electrons and gain of electrons. In both the process, the common thing is loss of electrons as well as gain of electrons. So this loss and gain of electrons simultaneously during a chemical reaction is called as a redox reaction. Okay, so repeating once again, a redox reaction is nothing but loss and gain of electrons simultaneously is called a redox reaction. So in this process we are going to observe both oxidation as well as reduction. So this is the common thing whatever we observe in the electrochemistry for both the processes. Okay. Right, so this redox reaction, we have to understand this one. Okay, so I am just putting it in the slide format. Redox can be split into two. One is red and ox. Red represents reduction and OX represents oxidation. Right, and reduction is nothing but gain of electrons. Okay, and oxidation is loss of electrons. Reduction is gain of electrons and oxidation is loss of electrons. To remember this very nicely, so there is a term called oil rig. So you can remember those first letters. From those first letters you can predict what is oxidation and what is reduction, right? Oil rig, O stands for oxidation and L stands for loss of electrons. So oil means oxidation is loss of electrons, and Rig, R-I-G, Rig, R stands for reduction, I is for risk, and G is for gain of electrons. So if you remember this term oil rig, you can easily remember what is oxidation and what is reduction. Okay, right. So to understand the basis of this redox reaction, we are going to apply these reactions in a closed circuit. We call it as an electrochemical cell. So to understand the basics of, to understanding the process of oxidation and reduction or redox reaction, we are going to see a setup which is called an electrochemical cell. Right. So electrochemical cells are usually classified into two, right, which we have seen already. One is voltaic cell, a galvanic cell, or an electrolytic cell. So I have shown you some of the examples for electrolytic cell and voltaic cell. So the famous example for electrolytic cell is your hydrogen oxygen generation or splitting of water to form hydrogen and oxygen by using electricity or electrolysis, and the other one is a famous reaction where you use two different electrodes, and by doing chemical reactions the electricity is produced. So these are two types of electrochemical reactions, and we will see its functions one by one in the coming slides. Okay, right. So before that, we have to understand what are the components of an electrochemical cell, right? So the components, there are few components which are necessary for to make an electrochemical cell. The first component is the electrodes, right? So electrodes are usually metals which are highly conducting in nature, and the mode of conduction here will be movement of electron. The mode of conduction here will be due to electron. So the first component in making an electrochemical cell is electrodes, and these electrodes are conductors, and the mode of transport here will be movement of electrons. So this is very much important, and these electrodes are connected each other by using a conduction medium. Mostly it will be in copper wire. Okay, right. The second component here will be the electrolyte, right? And electrolytes here also they will conduct, but the mode of conduction here will not be electrons, but the mode of electrons here will be ions, movement of ions. Here in electrolyte, the mode of conduction will not be electrons, it will be through ions, right? Right. So electrolytes are classified into two different types. One is a weak electrolyte and the other one is a strong electrolyte. By the term weak and strong, we say whether the material is easily dissociable or it takes more time to get dissociated, right? So strong electrolytes are material which can dissociate in its liquid state to its respective ions. Those are all strong electrolytes. Without any trouble, these ions get dissociated into its respective ions. For example, sodium chloride you can take, so which gets dissociated into its respective ions, right? And the other one is a weak electrolyte, and weak electrolytes take time, and they will be in an equilibrium with the undissociated salt, and the release of ions will be very, very limited. So weak electrolytes will take more time to get dissociated, whereas strong electrolyte dissociates very fast, right? So in this slide, I am showing you three different electrolytes which are commonly used to get an information about how the dissociation happens, right? So one is acetic acid. Acetic acid is termed as a weak electrolyte because it will be in equilibrium with the undissociated acetic acid. So the dissociation will be very, very less. So it will be a three-component system where there will be an acetate ion, where there will be a proton, as well as undissociated acetic acid will be there, right? So it will be a multi-component system. Now the other one is potassium chloride. Potassium chloride is a very strong electrolyte, right, where it gets dissociated into its respective ions, potassium and chlorine, right? So it's a strong electrolyte. The third one, what I am showing here is ethanol. Ethanol will not dissociate, so it acts as a non-conductor or it's a non-electrolyte in this case. Okay. So the next important part of an electrochemical cell is a salt bridge, right? Salt bridge is a setup. Okay, it looks like an inverted U, and in this inverted U-shaped glass tube, we will be filling an electrolytic solution. Okay, and that electrolytic solution, it can be in the form of a liquid state or it can be in the form of a gel state, where the ions will be moving from one end to the other. Mostly the electrolyte whatever filled in a salt bridge will be a strong electrolyte. Okay, so this is made of an inverted glass tube which will be kept between the two compartments of the electrochemical cell, right? So what is the purpose of this salt bridge, right? Salt bridge is very much needed here, because if salt bridge is not there, okay, during an electrochemical reaction, there will be formation of more charges in both the compartments. Both the electrolytic solution, there will be more accumulation of charges. If more and more charges accumulate at both the electrolytic solution, the potential whatever you are going to measure, that will lead to some error, because the charge produced, that will generate some potential, and the absolute potential of that electrode will be in an error, right? So to dissipate these accumulated charge, we use a component which can aid in removing this accumulation of charge. So the salt bridge does that purpose, where the electrolyte present in the salt bridge oozes out into the electrolytic solution and thereby neutralizes the excess charge developed in the electrolytic solution. Okay, thereby the charge neutralization happens, and once charge neutralization happens, there won't be any more accumulation of charges in the electrolytic cell, in the electrolytic beaker, and then the measurement or the potential whatever you are going to measure, that will be of more or less with less error. Okay, so these are the three main components used to make an electrolytic cell, and I have shown you a slide where all the three are being put together, and this is how it functions. The electrodes are used to transfer the electrons from one electrode to the other electrode using a copper wire, and the electrolytic solution contact by ions, and the purpose of salt bridge is to dissipate the excess charge accumulated in an electrochemical cell. Okay, so these are the components, and then we will see, this is a very interesting one, where you can see how the electrochemical cell functions, right? So how the electrochemical cell functions, we can see here. Here you can choose the electrode, or you can choose the electrolytic solution, and you can see how much amount of energy has been produced during this electrochemical reaction. You can see. So we have two different electrochemical cell, as I said. One is voltaic cell or galvanic cell, and the other one is an electrolytic cell. We will see both one by one, right? First we will see an galvanic cell or a voltaic cell, and how it operates and how it works. We will see this, right? So this is the setup, right? We got two beakers. In these two beakers, two electrodes has to be kept, and two electrolytic solutions has to be kept, and these two electrodes, these two compartments are connected through a salt bridge, and both the electrodes are connected through an external circuit and with an voltmeter, which will measure the amount of energy or potential produced, right? So in one we have chosen copper as the electrode, and the electrolytic solution will be 1 molar copper nitrate, and in the second compartment we chose silver as the electrode, and the electrolytic solution as silver nitrate, right? And once the connection is made, the charges starts moving from one electrode to the other electrode, and usually, if you remember, oxidation happens in anode, right? So here the anode chosen will be copper. So copper starts releasing its electron, and the electron moves through the circuit, and the ions moves into the electrolytic solution. So the electrons are moved through the electric circuit, and it goes to the other electrode, which is cathode, where the cathode, which is a silver electrode, that will accept the two electrons, and to neutralize this excess charge, it abstracts more of silver ions present in the electrolytic solution, which is silver nitrate. So what happens here, the copper is going to lose some of its metal in the form of metal ion, and the silver is going to abstract some of the silver from its electrolytic solution, right? So this is what happens in an galvanic cell, where one electrode gets degraded and the other one gets absorbed with more and more metal, right? So this is the function, and during this process, if you would have noted, the amount of electricity produced will be around 0.46 volts, right? So this is the amount of electricity produced via this redox reaction, where the copper electrode underwent oxidation, it lost 2 electrons and it forms Cu2 plus ions in the electrolytic solution, whereas the silver, which is a cathode, it abstracted 2 electrons and it get deposited with the excess silver on its surface. Okay, so this is the function of this is the function of a galvanic cell. Okay, now we will see, so this is another picture where you can see the zinc anode got disintegrated, whereas the copper get absorbed with more amount of copper, right? So this is the function of a galvanic cell, right? Now we will see the other one, which is the electrolytic cell. So here also we are going to see, we are going to use 2 electrodes, and instead of having 2 different electrolytic solution, we will have a single electrolytic solution. And here it's opposite of your galvanic cell, where the electricity has to be pumped into the electrodes to do some chemical reaction, because these reactions are not spontaneous reaction, they are non-spontaneous reaction. So in order to make it spontaneous, we have to supply excess current to the system, right? So we will start here and we choose the metal, right? So we will choose the metal as silver as the anode, and the cathode will be chosen as copper, right? And here we have an option of choosing the weight of the electrodes. So for convenience, we will keep it as 10 grams and 10 grams, okay? And the electrolytic solution will be a silver nitrate solution. Okay, the electrolyte will be a silver nitrate solution, right? So as I said before, if electricity is not given to this system, there won't be any reaction happening. So to fix this one, we are going to supply some amount of electricity to this system, right? So we will fix on to 1 volt current which has to be passed to this system, right? If the amount of current is lesser, the electrolytic reaction will not happen. So the voltage or the current, whatever you are going to apply, it should be of a minimum value, right? So here we fix to 1 volt, and we will start the reaction by switching on the switch. And once the switch is switched on, the current from the external circuit goes through the respective electrode, and it forces the redox reaction, right? So the electricity forces the electrochemical reaction or the redox reaction, where the copper, which is considered to be getting oxidized in the earlier one, now it undergoes a reduction, right? So because this reaction, copper undergoing reduction is not a spontaneous process, but this is achieved by applying electric current to the system. So what happens here, the silver undergoes oxidation, it loses its electrons, right, and it forms silver ions. The silver ion goes into the electrolytic solution, and the 2 electrons goes through the electric circuit, and it reaches the next electrode, that is your copper electrode. Once copper receives the 2 electron, it abstracts the silver ions present in the electrolytic solution, and it forms a thin layer of silver over its electrode. Okay, so so this type of deposition of the ion or the deposition of silver over the copper electrode will happen because of this excess electricity whatever passed to this system, right? So this is how an electrolytic cell works, right? And the concentration of the electrolytic solution can be changed, and changing in the concentration and changing in the temperature will also affect how much amount of weight has been deposited with the respective electrode, right? So we will stop here. Okay, and before winding up today's class, we will see a summary of whatever taught today. We started with the definition of electrochemistry, and then we saw what are the different principles or different types of cells available, right? And we saw what is a redox reaction, right? And we saw also different types of applications where this electrochemistry goes in, right? So these are some of the things whatever we saw in this class, right? And we will stop here, as I said, and we will proceed with the other topics in the coming classes, right? So in last but not the least, before winding it up, so there are some of the questions which I have posted, right? Please try to answer these questions. By answering these questions, you will get some more information about the topic, and it will be helpful for you to follow the coming classes. And the answers for these classes will be discussed in the next class, and then we will proceed on with the next unit. Okay, so the second unit, the second part which we will be seeing will be about electrode potential and how the potential is generated and how it works and how we can measure all these things. We will see in the next class. Okay, thank you for listening, and hope this session is informative for you. And if you have any doubts or if you have any clarifications, please do drop a message in my mailbox. So I will be happy to respond all these things. And thank you once again. Hope we will see you in the next class. Thank you.